other than exponential growth and decay, which are more scientific applications, there are some business applications for exponential functions, and the first one is compound interest. Most of you are probably familiar with simple interest. You take the principal times the rate times the time. It tells you how much interest is owed. Maybe, maybe not. Okay.
Yeah.
Well, compound interest is a little more complicated. Compound interest is an exponential function given by the formula. The total amount of money A is equal to the principal, which we'll assume is in dollars. That's how much you start with, the initial investment amount or the initial amount borrowed, times the big parenthesis, 1 plus the rate, R, and it's important to note that the rate has to be written as a decimal. So if it's not already as a decimal, you have to convert that interest rate to a decimal, divided by K. Now K is the number of times that your interest is compounded per year. So that's what K is. Rate R has to be written as a decimal. Then you close that parenthesis and raise it to the KT power. Now it really should also have a parenthesis here. Your book assumes you know that's there. Most of you will not have any problem with that, but if you're getting the wrong answer, make sure that you have your parentheses in the right spot. And some calculators, older ones, require a parenthesis here as well. So one more time. Compound interest is given by total amount equals the principal times 1 plus R over K raised to the KT power, where K is the number of times it's compounded per year and T is the total number of years. Got it? Okay. So here's an example. The parents of a newborn child invested $8,000 in a plan that's going to earn 9% interest and will be compounded quarterly. If the money is left untouched, how much will the child have in the account in 55 years? Because we all know he's going to leave that money alone for 55 years, right? Mm-hmm. Maybe if we don't tell him it's there. Well, so obviously from this phrase right here, compounded quarterly, we know we need compound interest formula. So we know we're going to use the formula. The total amount is equal to the principal times 1 plus the rate divided by K, which is how many times it's compounded per year, raised to the KT power, where T is the total number of years. So off to the side, let's fill in all of the variables. I know that capital P is equal to how much? 8,000. That's how much he starts with, and that's the initial investment. I know that R is equal to
0.09.
0.09. You have to change your rate to a decimal. What's K?
4.
K is 4, yeah. If I say it's compounded quarterly, that means I'm going to do it how many times per year? 4 times per year. So that's 4 times per year or every 3 months. So K equals 4. And T is the total time in years, which in this case is 55. If you substitute in those 4 variables, you should get the total amount after 55 years. So let's see what that turns out to be. I certainly don't expect you to do this without a calculator, so everyone break out their calculator, and we're going to round that to 2 decimal places because it's money, so we'll round to the nearest cent. So take a minute, make sure you can type that in. Tell me what we get.
$1,069,103.47.
That's a lot, isn't it? All right, you guys got $1,069,103.27. That's a lot, right? Yeah, seriously. That would be super smart. But here's the problem. You rarely find anything that guarantees you 9% interest, particularly compounded quarterly. Like, that's an extraordinarily rare situation there. So that's compound interest.
Because it's interest off of interest.
I would get mad at quarterly.
Do we need to talk about what the different compoundings mean quarterly. Annually would be how many times a year?
1.
Semi-annually,
2,
monthly,
12,
weekly,
52,
daily,
55.
unless it's a leap year, then it's 366.
That is some good interest.
It is. We would also like to talk about continuous interest in this section, but to do that, you need to have an understanding of the number little e. Little e is known as the natural base because it occurs in nature. And it's actually an irrational number, and it's approximately 2.7182818284594. Okay? So if you're familiar with that to about 3 decimal places, that's pretty good. But I don't want you to ever use a rounded version of E since you have access to a good calculator. Notice that you can find E on your calculator in 2 spots. You can find E under the second natural log, but that raises it automatically to a power. But if you put a 1 in there, that'll give you E. Or second divide. Second divide brings up E without a power. So if you just want plain E, second divide will bring that up. So those are the ways you can find E on your calculator and use it to calculate things. So that brings us to the continuous compound interest. You will always know a continuous interest problem because it will say compounded continuously. So rather than a set number of times per year, it's done just all the time. It's steadily tallying up your interest. If P dollars are deposited in an account earning interest at an annual rate of R, compounded continuously, the amount A after T years is always given by the formula A equals P times E to the RT power. It's sometimes called the PERT formula. A equals P times E to the RT power. Now this is how I memorized it with the parentheses there. So you might want to know both of those. That is called continuous interest. Okay, so for the final example, let's say that we take that previous example, the parents of the newborn baby. They do the same basic thing. They take $8,000 at an annual rate of 9% interest, but this time they find an account that compounds the interest continuously. We want to know how much would the child have in the account in 55 years. So this time, instead of K equaling 4, we're going to have continuous interest, which means we need a new formula. P times E to the RT power. Not the KT, the RT. There is no K in continuous interest. So we have 8,000 times E to the RT. And don't forget to convert the 9 to 0.09. Then multiply by 55. And let's go to the calculator and see what we get. We have 8,000 times E to the RT power. So what's that turn out to be? 1 million. Okay, read it to me again. 1,129,399 $399.71. Okay. So a little bit better than compounded quarterly, but not as much higher as you thought it would be, right? I mean, I really thought it would be a lot more, but it turns out not to be too terribly much more. Any questions about continuous interest? All right, well, that's the end of section 4.1.